Hello. In this video, we introduce 4 basic ways to measure your central tendency of your dataset. Let's get started. So to begin, the easy part of this lesson is that all 4 of these measures of central tendency start with the same letter, and you've probably heard of most of them before. The mean, the median, the mode, and the midrange. So let's take a look at what they mean again. No pun intended. The mean is known as the average of your sample's data values. So remember that when we're talking about a sample, there could be n items in our sample. That's called our sample size. And the number of data values is represented by n. But each data value takes on a different number, right? So that could be representing the ages that you're talking about, or the IQ scores, or cholesterol values, whatever it is. Each of those then could be represented by a variable, a letter that represents changing numerical values, called x. So in order to get the mean, which we learned in our previous video for a sample is x with a line on top, sometimes read x bar, bar x, we would say that is found by adding up, remember capital sigma, that Greek letter means the sum, adding up all of our data values, so every x value, add them together, and then divide by the total number of values, that's n. In other words, you're taking a simple average, okay? So if you look at, for example, the box at the bottom of the screen, it says the ages of students in a particular class. And we see here that these students age anywhere between 20 to 65 years old. That's the spread, if you will, between 20 and 65. We'll talk more about what that spread means next video when we talk about measures of dispersion. But for now, looking at that data, we can find the mean or the average by simply adding up the actual values and dividing by the number of them. So in this case, that's what we're doing here with our formula. To find bar x, to find the sample mean, we are simply adding up 20 plus 20 plus 20 plus 20, et cetera, all the way through 65, and then dividing by the number of items. And here, if you add them up, there appear to be 20 items. So our sample size for this sample is 20, okay? So when you divide the total by 20, you end up getting approximately, notice it doesn't say equal to, but it has a squiggly approximation, approximately 23.8 years. Now, a good technique for your measures of central tendency is to always round your data 1 decimal further, 1 more decimal than the original data was given to you. So since we had whole numbers, right, in the ones place as our final digit here, we're now in the 1 decimal over. We're in the 10th place for our rounded value. So if you actually look in your calculator and add up those numbers, divide by 20, we actually rounded to get that number. And that's why we're saying there's an approximation going on here. Now, the second measure of central tendency I want to introduce here, and I'm sure you've heard of it before, is called the median. What do we mean by the median? Well, one thing you can remember easily is when you're driving, at least in America, when you're driving on a freeway, you typically have a median in the middle of your road, right, dividing the 2 different lanes of traffic. So when we're talking about median, you just want to think middle, right? It's directly in the middle of your data. Now, there is a catch, okay? The catch is your data has to be what we call sorted from low to high. So you notice here all of the data started at the lowest value of 20 and went up to the highest value of 65. If your data is not sorted, you cannot find the median right away. You have to first sort your data and then look for that middle value. So that middle number, if it's easy to find, it'll be right in the middle, is your median. Now, sometimes it's not as obvious. For example, if you look at the data set we're given here, we have 20 students' ages in this data set, okay, between 20 and 65. So how would I find the middle number if I listed all 20 of these ages from smallest to highest? Well, I could go to the middle and I say, well, there's a 10th value. Let's see where that is. My 10th value for this median here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10th value. And then my next value, the 11th value, is here at 22, okay? So in this case, because there is an even number of data points, in other words, your sample size n is even, you need to go to the halfway point of that number. So n divided by 2 is 10. 20 divided by 2 is 10 in this case. Go to your 10th value and then the next one, in this case is 11. Go to the 10th and 11th value and find their average. So that's what we did here. We found the average of the 10th and 11th values. This one's kind of obvious, right? Between 21 and 22, you're right in the middle at 21.5 for your median. But you actually could also do the calculation, 21 plus 22 divided by 2. So basically, if you have write this in your notes, if you have an even number of values in your data set, you will need to go to the halfway mark, So if it's 100 values, go to the 50th mark, and the 50th and 51st item, you're going to take their average. That's how you'd find the median. On the other hand, if I just had 5 values, that's an odd number of values, I can simply go to the third item, and that would be my median, assuming, of course, that I have sorted my data from small to high. Okay, so why do we talk about the median? Well, the median is actually the best, I'm going to fill in my blank here, it is your best measure of central tendency. It's actually telling you, better than the other 3 options that we're talking about today, it's telling you the best way to know where the middle of your data lie, okay? Why this is important? Let's talk about, for example, housing prices, right? Sometimes you're looking at the housing market and you're thinking, oh my goodness, I can't afford a house. Well, that might be where you're at, okay? I've been there too. And that might be because you're looking at the average housing price, right? And to get the average, you can look back to what we just did above with the mean, right? We took all the values and divided by the total number of them. So if you took all of the housing prices of houses that are for sale in your area and divided by the total number of houses for sale, that would give you the average price. But keep in mind what that includes. That includes all of your very expensive homes, the multi-million-dollar homes, if you live in an area such as this. It also would include, back in like 2008, there was like big housing crisis. It had lots of foreclosures. So if you have a lot of foreclosures in your area, maybe homes that are only selling for $10,000, $20,000, $30,000 when they normally would sell for a lot more, then you'd be including those extremely low numbers as well as the extremely high numbers in your data. Okay? Now that would be problematic because it would tend to tell the reader an average that does not appropriately describe what's happening in the middle of our data. Okay? So rather than doing that, we prefer to use the median. We're going to look directly at the middle and see here is where most of the housing prices are in the middle of the pack. And we're going to ignore those outliers. That's the beauty of a median. It's the same thing I do with my test scores. If someone didn't study at all and they got a 0 on the test and somebody else got 100 on the test, both of those tend to pull your average one way or the other. But if I tend to look right in the middle of my test scores, that gets me a better idea of where most people are. Okay? So the median is the best measure of central tendency. All right, let's talk about another measure of central tendency that's still important to discuss, and that would be our mode. When we talk about the mode, another way you can remember that is the first 2 letters of mode, right, are also the first 2 letters of most, right? Most frequent, most popular. That's what we're talking about with the mode. It's if there's a particular data value or multiple data values that occur more than one time and more than all the rest, then we would say that is the mode of our data. So let's take a look at this situation where we have students' ages. It does appear that the number 20, the age of 20 years old, is appearing multiple times in my data set. Here it is once, twice, 3 times, 4 times, 5, 6 times, because the data is sorted, we can see it easily. 6 times the age of 20 appears in my data set. Now I also noticed that 21 appears multiple times, once, twice, 3 times, 4 times, and 22 appears once, twice, 3 times. 23 appears once, twice, 3, 4 times, okay? So we notice here that there's multiple repeats of values. What we're looking for the mode is which one wins, right? Now, if they all only appear once, there is no mode. But as long as there's someone that was repeated, you then have to decide who the winner is. Now, there could be a tie. Notice in this case, 20 appeared 1, 2, 3, 4, 5, 6. If, let's say, the number 23 also appeared 6 times and no one else had more appearances, then they would be both considered modes. We'd say that we have a bimodal data set. But in this case, we only have one that appears the most, and that would be 20 years old. So it's occurring most frequently or with the greatest frequency. Now finally, the mid-range is very interesting. Now the mid-range, it kind of does the opposite to what the median does. Remember what we said the median does? It looks directly in the middle of your data, ignoring all of those extremes, right? Whereas the mid-range, it's very easy. You don't have to look at all of the data. You're just going to look at the lowest value and the highest value and then take their average. That's it. So you're basically looking at the spread of the values and then taking an average of those two. So 20 plus 65 divided by 2 gives me 42.5. Now if you look at all of these different values that we just collected and we analyzed here, we had our mean at 23.8. We had our median age of 21.5. We had the mode, the most common age here, of 20. And we had a mid-range of 42.5 years old. Okay. Do you notice one of them appears not like the other? That's right. The mid-range is actually the one that is most impacted by your extremes. And in this case, the extreme age or the outlier appeared to be the person who was 65. Again, you're welcome to be 65 in my class anytime. I love students of all ages. But keep in mind, in this particular data set, that was the outlier, right? And so if you're trying to minimize the impact of outliers, you wouldn't necessarily want to use your mid-range as your best measure of central tendency. Rather, the best measure of central tendency will always be your median. Now, we'll talk about in future videos something called a bell-shaped distribution of data, and in that case, your mean, your median, and your mode should all line up exactly at the same value if you have a perfectly normal bell-shaped distribution. But the mid-range is still nice. It's a nice, quick and dirty way to get an idea of where the middle of the data might be. But again, with those outliers, you can't really trust it to really measure the central tendency well, as you can tell here. All right, when you think you have your notes squared away, let's head over to our first example. This example asks us to find the mean, the median, the mode, and the mid-range for these ages. Now again, you can use technology to do this quickly, right? You can use a graphing calculator, a basic calculator, Microsoft Excel. There's all kinds of programs that can do this quickly. But what I want you to do is understand the concepts here. So I've chosen a pretty small sample size so that hopefully you can use a small basic calculator to do this by hand, just so you can get an idea of what they mean. So here we're talking about ages of people again. Maybe these are students, we are not told. And it looks like we have sorted the data for you, which is very kind, okay? Typically, you'll need to sort your data first before finding the median. You always have to sort before you find your median, okay? And it just makes it easier for the whole thing. So let's take a look at the first one. Do you remember how we find our mean? How do we find the mean? That's right, that would be X bar for our sample. Okay, when you get into statistics class, we'll have a different letter. It's called letter mu when you're talking about the mean of a population. But for our sample, it's just X bar. And it was the sum of the values, so capital sigma of all your X values, your data values, divided by the number of values in your sample. In other words, your sample size. And in this particular case, if you do this, you'll get 25 plus 36 plus 39 plus 45 plus 49, et cetera, all the way until the highest value of 95. You add them all together, pause the video, see if you get the same number I did, just to check your calculator skills here. Did you get 2058? That's what I got. And how many values are represented here? In other words, what is our sample size? Did you get 30? That's what I got too. Okay, so there's 30 items in the sample. The total number of all of the values added up, the ages added up, was 2058. To find the average, you add them all up and divide by the total. Same as we've always done for averages, right? Now when I do this, I will get a number that I need to round, and in this case, I'm rounding again 1 decimal beyond the data, so I'm going to round to the 10th place, and I get 68.6 as my sample mean, okay? So that's my sample mean here. And let's see how close all of our data values are. Remember, if the mean, median, and mode are very close together, it's more likely that you have what's close to what we call a normal distribution of data. And it's very rare, but when it does happen, it's very helpful. Next up, let's take a look at the median, okay? To find the median, remember you first have to sort your data, and they've already done that for us, which is a big time saver. Again, software can do that for you, whether you're using Excel or a graphing calculator. Median, so what do? Well, first of all, you remember that we have to ask ourselves if the sample size, the number of items in the sample, is even or odd. And in this case, it is even, 30, right? So we have to go to the halfway point and then the next point and take their average to find the median. So half of 30 is 15. So I go to the 15th value and the 16th value and I take their average. So let's take a look where that would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's what I thought, 68. And then I look at the next one, the 15th value, 70. Now this one's, again, very nice numbers, so hopefully you can see the number right away. But when you add them and divide by 2, what do you get? Exactly 69. Now to be consistent though, you'll want to go 1 decimal beyond that. 69.0 is our median. Notice how close those numbers are. So this data does appear to be pretty close to what we call bell-shaped so far because those numbers are pretty close together. Not a guarantee that it is bell-shaped, but the closer that those three are together, mean, median, and mode, the more likely you're dealing with something almost normal. Okay, let's take a look at the mode now, the most common value. Do we have a mode? Remember, sometimes we don't have a mode. Well, the first thing you'd have to ask to figure out if there's a mode or not is if any of the values occurred repeatedly, right? And do we see that happening in any of our data here? I do see that happening with 65. It happens a few times. 68 happens 1, 2, 3 times as well. Okay. Who else? 71 happens twice. 72 happens twice. 85 happens twice. 87 happens twice. Anybody else? Now let's see if I missed any. Yeah, so in this case, you're looking at something that might be what we call bimodal, right? So in this case, I would say that my mode, unless I'm missing something and you can catch me later, it looks like I have 65 appearing 3 times and I have 68 appearing 3 times. There's a tie for most popular. So my mode, in this case my modes, would be 65, and again we'll do 0.0, as well as 68.0. Okay, so you can have bimodal data sets. That can happen for sure. You can even have trimodal data sets. So just have to watch carefully and make sure. Okay, so next up, again, now that number is a little bit different, right? It's not very close to 68.6, the mean, or 69.0. You could argue that 68 was, but the 65 here, it definitely looks a little bit further away. All right, so let's take a look at what we call the mid-range next. Now again, that's one that's usually, if you're going to have some variety, that's the one that's going to be a little bit skewed because of the outliers. Let's remember how we found the mid-range. So to find the mid-range, what do we do again? That's right, we just look at the outliers and get their average. In other words, the extremes. The lowest value of 25 plus the highest value of 95, and divide that number by 2. So when I did that, 25 and 95, I got 120. Hopefully you did too. Divided by 2, I'm getting 60 or 60.0 as my mid-range. Okay. And again, that is a little further away from where the other ones are. So we don't have a perfectly what we call normal distribution that we'll talk more about in future videos, but we have practiced these important skills of calculating the mean, median, mode, mid-range, and understanding their differences. That's really what we're after in this video, more than you being perfect at arithmetic, right? We know that technology can do all of this for us, but we want to understand the basics of what each value represents. Okay, when you're ready, let's head over to our next slide. Can you do that again, but this time for cholesterol values? Sorry to be a bummer if you're getting your values checked soon. All right, so it's asking us to find the mean, median, mode, and mid-range for these cholesterol values. All right, so again, one of the things I noticed, it does appear that they have sorted my data for me. 132, 153, 176, it keeps increasing all the way up to the 285. It looks like a total cholesterol score here. Okay, so finding the mean, go ahead and pause the video, try it all on yourself, by yourself here, see if you can do it on your own. Okay, so when you found the mean here, what did you do? Well, hopefully you noticed that there were 10 items in the data set. N is 10, which is even again. So we're kind of a pro at what that means now, okay? And then what do we do next? That's right, we added up all of our data values and divided by N. So when you did that, 132 plus 153 plus 176, 182, 195, 200, 202, 214, 248, 285, did you get 1987? All right. Hopefully. And dividing by 10, you end up with 198.7 exactly this time. No need to round here, right? Okay. So that would be what we call the average cholesterol value from this data set of individuals, okay? But next we're asked to find not the average, but the middle number, right? The median cholesterol value from this data set. These are probably different individuals because this would be a lot of variety for one person, unless it's over the years and things are just getting bad. All right, take a look at the median here. The median is the middle value, and because we have an even number of values, what did we do again? That's right, we cut that number in half, so there's 10 values. 5 is the halfway point. 1, 2, 3, 4, 5 of my sorted data, that's key. And then the next one is the 6th value. So I would take 195 plus 200, take the average of my 2 middle values, and what did we get when we did that? Did you get, divided by 2 of course, did you get 197.5 without having to round it all? That's what I got. And again, those numbers are pretty close, the mean and the median so far, so it's a nice compact set of data that approaches what we call a normal distribution potentially. Let's take a look at the mode. Okay, so the mode is our most popular or most frequent value if there is repetition of values. Do you see any cholesterol values that are repeated here? I'm looking carefully. I don't see any. So for mode, I would say not applicable or there is none. You could just say none. I'm just being lazy. It's a very ugly D, so I'll try to make it prettier. Not much. Next up, let's head over to our last measure of central tendency, the mid-range. Remember, if there's one value that's going to be different from the rest because of your extremes, it would be the mid-range. So what would our mid-range have been when you did your math here, your arithmetic? What did you get? For mid-range, again, we're only looking at the lowest value and the highest value and taking their average. So 132 plus 285, take their average of those two values, so divide by 2, and what did you get? Well, I got 417 divided by 2, which not rounded, but became exactly 208.5. No need to round there. Okay, that's a lot bigger, and again, that looks like it was heavily impacted by the extremely high cholesterol value of 285. So that brought up the mid-range, even though the 132 you'd think would have drug it down a little bit more. Okay, but still not terribly far from where the mean and the mid-range of the sample are. Okay, so now we've practiced these 4 measures of central tendency. Before we go in this video, I want to introduce one more topic. Let's see if we can talk about one more topic here, and that is the topic of quartiles. And you may have heard of this before if you've ever done anything along the lines of standardizations, when you're talking about whether it's a SAT or an ACT score, and you look at your report at the end and it says your math score was, let's say, a 700, your English score was a 700, and you think, oh, I did the same on both of them. But then it tells you your math score was in the 3rd quartile, or maybe they said the 75th percentile. Or it says your English score was in the 80th percentile, okay, or maybe the 60th percentile. That's telling you relative to everyone else, here's how you did, okay? So it's not a concrete, here's your score, it's a score that is relative to others. And they do this also when you're measuring your children. If you take them to the pediatrician and they weigh them and they take their height, then they look at this curve and they want to see, are you in the 1st quartile, the 2nd quartile? They want to make sure that you're not terribly an outlier compared to the rest of the population. That's what we're looking for here. So when we're talking about quartiles in general, the first thing we want to notice is that there are 3 quartiles that we're going to be finding, okay? So the 1st quartile, the 2nd quartile, and the 3rd quartile are basically the 25th, the 50th, and the 75th percentiles. So they're just 3 special percentiles that are very easy to calculate if you understand the concept of the median. As long as you understand how to find a median, you can have your quartiles, no problem. So what do we have to do to find the median? We always had to have our data, that's right, sorted from low to high. So if you sort your data from low to high and you know how to find the median, there's no problem finding quartiles. Okay, you don't need any fancy technology at all, unless you have a lot of data that you don't want to waste time doing by hand. All right, so how do we do this? To find the 50th percentile, that's where we want to begin. That's quartile 2. We just need to understand that that is the median of the data, okay? So if I know how to find the median, I know how to find the 50th percentile. So take a look at the ages here. We've talked about, I think, before. 24-year-old, a 52-year-old, a 27-year-old, a 40-year-old, a 25-year-old, a 55-year-old, a 30-year-old, another 30-year-old, a 44-year-old, a 26-year-old, a 32-year-old, a 50-year-old, and a 57-year-old. Okay. How many people did we just talk about? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I think that's right. Okay, so we have all of our data there. The next thing that we'd want to do is to put them in order, and that's what they've done for us here. They've sorted our data for us. So they did our 24-year-old, they did our 25-year-old, there we go. They did our 26-year-old right there. They did our 27-year-old right there. They took care of a 30-year-old here. Oh, I see what happened. I think I had too many 30-year-olds here. So in your notes, I'll change that for later. Go ahead and delete that second 30-year-old. That was a typo your professor missed. Okay, so only one 30-year-old here. Okay, then we had a 32-year-old. Then we had a 40-year-old, a 44-year-old, a 50-year-old, a 52-year-old, 55-year-old, and 57-year-old. Okay, so we've now taken, again, the correct number should be 12. There are 12 ages of people here supposed to be represented. Now, could it have been 13? Yes, but since I'd already created this for you, let's keep the 12 that way. So we've sorted them from low to high always. Now to find the second quartile, I almost said the first. To find the second quartile is the very first step here. And what we do is we find the median. So what we did then is we said cut 12 in half, that's 6. So 1, 2, 3, 4, 5, 6. This is our 6th value, and the next one would be the 7th value. So the very first step is to find the median of your sorted data. So that's step 1. If you find the median of your sorted data, you're going to have quartile number 2. We'll talk about that in a moment. So let's do that. 32 plus 40 divided by 2. Does that give you what they found here to be 36? It looks like it does. And we would normally write this as 36.0 to be honest, okay? So 36 or 36.0 would be our median. We call that quartile 2. Now let's talk about what that means. That is telling you, if you think about like quarters in a dollar, there's 4 quarters in a dollar, 25, 25, 25, 25, right? What we're saying for quartile 2 is that there are 2 quarters before it. So that'd be 50%, okay? 50% of all data values that were represented here are below the number 36, okay? So if you are measuring right at quartile 2, 36, if you have a value of 36, if you're a 36-year-old, right, then you are older than half the population here, right? 50%. That's what it's saying. So a value of 36, a 36-year-old here would be older than 50% of the population in this particular survey. Okay, once you have that, you can head over to quartiles 1 and 3. So that's step 2, if you will. Find quartile 1. How do you find quartile 1? Well, that's the 25th percentile. So that means if you find that value, you know that value is higher than 25% of the population, and it's also smaller than 75%, okay? So what that means here is you want to find, for quartile 1, the median of the lower half of your data. So you look right below 36 and you say, okay, which of my data are right below 36? Well, that would be 24 inclusively to 32, okay? How many values are there in that grouping? 6, right? And again, that's even, so I can go right to the halfway point, which is the third value, and then the next value. And I would be finding the median of those 2 values, the median of my lower set of data that's below the quartile 2 median. Well, this would mean 26 plus 27 divided by 2, which should give me 26.5 exactly. And that would be quartile 2. What does that mean? Well, that means if you're 26 and a half years old, then you are older than 25% of the people who were sampled. You're also younger than 75%, right? Because the percentage adds up to total to 100%. Finally, we can talk about quartile 3. To find quartile 3, I think you know the idea now. For quartile 3, it's also known as the 75th percentile. So it's the marker that separates the bottom 75% from the top 25%. Okay? So if you are right at the 75th percentile or quartile 3, that means that your age is higher than 75% of the people in this sample. Okay? So let's take a look at what this means. We need to find the median of our upper half of the data. So we look beyond 36, that would be 40, all the way to the highest value of 57. So again, there should be the same number as last time, 6. So we go to the third and the fourth, so the halfway point and the next one, and take their average. So to find quartile 3 here, that's what we did. We took the third value above the 36 here, that would be 50, plus the fourth value of 52, and divide by 2. And when you do that, what do you get? Exactly 51, right? Or 51.0. So if you're a 51-year-old in this particular sample, that meant that you were older than 75% of the other people in this sample, okay? And maybe this is important if you're doing if you're a test subject for a type of pharmaceutical, right, the drug that's coming out, and they want to know how many people of this age took the drug, and now you know this is where you rank as far as age goes compared to the others in the survey, right, or in the sample. Okay, so quartile 1, 2, and 3 are basically cutoff markers for a group of data that are going to tell the reader if you're below this number, you're going to be in this percentage of the population, okay? So it's very helpful to understand how you relate to the rest of the population in the sample. Okay, let's see if you can put this into practice with gas prices when you're ready. It says find quartiles 1, 2, and 3 for these gas prices across the nation. It looks like these were from a previous time when gas prices were low. $1.72, $1.79, $1.87, $1.89, $1.91, $1.93, $1.95, $1.98, $1.99, another $1.99, $2.01, $2.05, $2.06, $2.09, $2.11, $2.12, $2.15, $2.15, $2.25, and $2.49. So again, they've done us a huge favor. They've sorted our data, but that's always where you need to begin. So step 1, make sure this is in your notes, always sort data first. Your professor was a little bit too nice to you in this video. Always sort data first from low to high. Okay, once you've done that, that's half the battle, okay? The next thing you want to do is which quartile do we specialize in? That's right, we want to find the median. Why do we find the median first? Because that is quartile 2, okay? That's going to cut our data in half. So here we've nicely visualized it so you can kind of see, but let's count how many gas prices we had total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, double, that's 20. So there are 20 gas prices that we're talking about in this grouping or sample. So to find quartile 2, or the median of all the data, go to the halfway point. These have all been medians of even data sets so far. If it had been odd, it would be really easy just to go right to the middle number, no average needed. So we go to the 10th value, which would be $1.99, and the 11th value, which would be $2.01, and we take their average. So $1.99 plus $2.01. You can see easily, hopefully, what this one is right away at just $2. Now let's practice, though, again, rounding. Where do we normally round our measures of central tendency? That's right, 1 decimal beyond the given data. So even though you usually only talk about the, as for your penny, when you're talking about money in the USD currency, we usually stop at the 100th place. But in this case, we're going to go to the 1,000th place. So this would be 2.000. Okay, and even at some gas stations in the US, you'll see that sometimes, that they use that 3rd place as well, but it's kind of smaller print. Okay, so this would be $2 even, the average gas price from all of these samples across the nation at a particular point in time. All right, once we found that, we recognize what that means, right? Quartile 2 means that half of the gas prices are lower and half of the gas prices are higher, because quartile 2 is the same as what we call P50, just so you're understanding. It's your 50th percentile. Okay, once you found that, you can now find quartiles 1 and 3. So to find quartile 1, do you remember how we did that? I'll do this one with you, and then you can find quartile 3 on your own. That's right, it was the median of the lower half of your data. So the lower half of our data has to be below quartile 2, $2. So that would be stopping at $1.99, starting at the low of 172. In that grouping, there's 10 items, so we go to the halfway point to find the median. We go to the 5th place, 1, 2, 3, 4, 5, that's $1.91, and the 6th place, and take their average, right, since it's even. So this would be $1.91 plus $1.93 divided by 2. That should be easy, right? $1.92, and then we tack on an extra 0 because we're trying to be consistent with our notation here. One more data place than we were given. So hopefully that's what you got as well. Let's see what you got for the 3rd one. Last step, find quartile 3. How did you find quartile 3? Yeah, that's right. You wanted to take the median of the upper half of your data values. So above the median of $2, that would be the 201 all the way to 249. So we again go to the halfway point, the 5th value there of 211, and the 6th value of 212. So 211 plus 212 divided by 2 should give you 2.115 exactly, right? Now, you could say that rounds up to $2.12. If you notice at a lot of the gas stations, they won't actually round for you, so you think you're paying $2.11, but it really was $2.12. So pay attention to that if you have time. Okay, so again, what is this saying? Well, if you went to get gas, according to this period of time, and you paid $1.92, that means 25%, because this is P25, that is what we mean by quartile 1, 25% of gas prices were below you and 75% were above you. But if you paid $2 and let's say 12 cents for your gas that day, that meant 75% of people paid less than you and only 25% paid more, because this is what we call P75, quartile 3. Okay, so hopefully that starts to make some sense. Again, technology can do all of what we did today a lot faster. So I'm not saying never use technology, but what we want from this class is for you to get a basic idea of what these concepts mean, no pun intended, so that when you are in the real world and you hear about these concepts, you know what it is they're saying and why they're using these words and not other words. Sometimes they're trying to manipulate you, just saying. All right, if you have any questions, feel free to ask me. Reach out to me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.